may not be review material, but the first couple of sections that we're going to talk about tonight are not too bad. So, I'm going to dim the lights here. All right, we're going to talk about absolute value, and one of the first things that we talk about with absolute value is its raw definition of what absolute value really is in terms of mathematics. An absolute value is the distance from zero. All right, so when we talk about the absolute value of a number, we're talking about how far is it away from zero on a number line. So the absolute value always, when we take that, the absolute value of a number, like absolute value of 3, straight up and down sticks on each side, that's the absolute value marks. It's 3. It always produces a positive answer because distance is never negative. Okay, so anytime we're just evaluating an absolute value problem, if we did a different problem, -3 inside absolute value on a number line, the whole idea here is that if I can draw a straight line here, on a number line, zero's right here. 1, 2, 3. 3 is 1, 2, 3 hops away from zero, right? But -1, -2, -3 is 1, 2, 3 hops away from zero as well. So it's the same distance away from zero. So the absolute value of -3 is that same number 3. It's the distance it is away from zero. So when we're dealing with absolute value, just keep in mind that it's a distance away from zero that we're looking for. And when we start doing equations and inequalities with this, we're going to kind of revisit that number line idea and figure out some things about those, especially the inequalities. The equations are a little more, it's pretty straightforward, but the inequalities can somewhat get confusing sometimes. If you're dealing with order of operations in absolute value marks, the absolute value marks are the same rank as parentheses because they're like a grouping symbol. So any work that we need to do is done inside of the absolute value first. So like maybe you had 5 minus 8 inside of the absolute value. Well, you're not taking the absolute value of each one individually. You're doing the work inside first, and that's going to be the absolute value of -3. And then we already know that that's 3, right? So it's order of operations wise, it's the same ranking as a parentheses or a bracket, in the parentheses, exponents, multiplication, division, addition, subtraction, in that order. If there's a number on the outside of that absolute value mark, maybe it's a -2 on the outside. It's just like if there were a -2 on the outside of a parentheses. It's a multiplication type thing. So maybe you got -2 and then the absolute value of -6. Well, again, order of operations ranks here, and we need to work out the absolute value part first. So the -2 is just going to hang out, and then we're going to get the absolute value of -6 is 6. And then we multiply -2 times the 6 and get an answer that is -12. You want to work out the absolute value parts first before you work out anything to do with any multiplication or anything outside of there first, because the order of operations ranks there. One of the problems that can sometimes confuse folks is when they just throw this at you. They'll put a little negative sign out there in the front, and then they'll put a number in there, and it'll be like absolute value of 5, but with a negative sign in the front. And a lot of times we get confused about that because we think, okay, it's absolute value in the problem, so we know the answer should be positive. Well, it is for the absolute value of 5. It's +5. But really, this negative in the front is like a -1 sitting out there waiting to multiply. So it's really -1 times the absolute value of 5 is 5. And then that gets us -5 as an answer. So you've got to be careful of that. Just simple simple things that can sometimes cause us a little issue with this. Kind of extending that a little bit is when they ask us to evaluate and then they give us some letters, x equals -6 and y equals 10. Maybe they're giving us that stuff in the directions they want us to evaluate. Remember, evaluate just means find the answer to work this out, get the answer to it. And they might have something like absolute value of 2x minus 3y, like that. And our job is to evaluate that using what they told us for x and y. So we're going to plug those in the right spot. So 2 times -6 and 3 times 10. And again, order of operations is always going to be the way to do that. If you want to do it by hand, you can. That's easily done. So that'd be -12 and then -30. And it's all in absolute value. And then absolute value of -42 is what that works out to be, which is 42. If you don't trust yourself, which sometimes when we get a lot of negative signs in there, we want to kind of check ourselves a little bit. It's easy to do with the calculator. You can just work out the stuff inside there. So we got 2 parentheses -6, oops, minus 3 parentheses 10. We work that out, we get the -42, and then we can take the absolute value of that. When we know that answer is going to be positive. If you wanted to put the absolute value in there, you can hit math and then go over to number. Remember that ABS, that first option is absolute value. And then you just type in your number that you want to take the absolute value of, and it's just going to crank that back to you. You could even do that at the beginning if you wanted to. I usually don't because it's only one little thing, but you can do that if you want. Just doing it exactly like I've written it. Just type it in there and hit enter, and it cranks out the same answer. So there's a lot of ways that you can use your calculator to help you out when you're evaluating there. And this one's a little tougher. It's got a few absolute value marks in it, which can sometimes confuse us. So I'm going to try to make those a little thicker so they don't look like ones. All right, so we got 2 absolute value of x minus the absolute value of 3y. All of that divided by the absolute value of x times y. So the first step would just be, plug in the stuff that we know x and y are. So absolute value of -6 minus absolute value of 3 times y, which was 10 again. And then on the bottom, we got absolute value of -6 times 10. And we're just going to work out each individual part there. So it's kind of like what we talked about Tuesday. It's a big problem. Just take it one piece at a time. So the absolute value of -6 we know is 6. So I'm just showing every step here. And then we got absolute value of 30 under there, inside of that. And then on the bottom, we got absolute value of -60. So I'm just showing every single step that's happening there just so we know where things are coming from. So that'd be 12 minus 30 over 60. So it's just evaluating that multiplication and then the absolute values. And then the last step would just be, do that subtraction. 12 minus 30 is -18 over 60. And then, with my calculator, I can go -18 over 60. And it'll give me mine's set up to give me a decimal back, but I can just hit math, enter, and it'll change it to a fraction for me. Math, enter, always will change an answer to a fraction. And I want that as -3 over 10. that would be your final answer. Always reduce as far as possible. And if it's written as a fraction in the beginning of the problem, their answer should be written as fraction too. That's always kind of my rule of thumb for that stuff. So absolute value is distance away from zero, and then we know it's always going to be a positive result. And order of operations wise, it's in the ranking of a parentheses, and that's really the review part of absolute value from that first section. So in just a few minutes, we've covered one section already, so we got 2 to go. The next 2 are a little longer, so don't get too excited that we're going to get out of here by 5 o'clock. So it's not going to be that early, but it won't be too late either. All right, so the next section, we jump over into chapter 1 in your textbook, and toward the end there, section 8 of chapter 1. And this is where we're going to talk about absolute value equations and inequalities. So there's a few things that are going on here with absolute value equations and inequalities. Equations are the easier part. We're going to start with that, and then we'll get into the inequalities. And there's a few rules that we need to remember about inequalities to help us set them up to solve. The solving part isn't going to be too difficult with this, but the setup is the most important part when it comes to solving absolute value equations or inequalities. And we're going to have to keep in mind that absolute value is a distance away from zero. So when we have an equation, and we'll start with the most simple one that I can give you, and that would just be an absolute value of x is equal to a number. Let's say that number is 6. What that is saying is that there's something, we don't know what, it's x, it's a variable, but whatever that is inside of the absolute value, it has a distance away from zero of 6 units. Okay, and we know, kind of revisit that number line idea, that if 0 is right here, how, what has a distance away from 0 of 6? Well, positive 6 does. That makes sense, right? What else does? Negative 6 also does, right? They're both 6 units away from 0. We could count that out or measure it with that. So because of that rule, that absolute value is a distance away from 0, and that there are 2 things that could possibly do that, that means we're going to set up 2 equations. We're going to set up whatever's inside of the absolute value. In this case, it's just plain x, so there's not going to be much to do. One of them is going to be equal to 6, because 6 has a distance away from 0 of 6. And then the other one is going to be x equals negative 6. If there were anything with the x there, like a 2 or a x plus 5 or something like that, we would have to solve those. But since that x is by itself, we don't have to do anything on this one. We're going to get some where we got to do some work. Obviously, we can't have them all that easy. But the idea is that, hey, it's a distance away from 0. Whatever's inside of the absolute value marks has this distance. So it could be at a positive 6 or a negative 6. Let's take that idea and put it with a little bit, tougher problem. Maybe something like x plus 4 is equal to 6 in the absolute value. So absolute value of x plus 4 is equal to 6. So it's the same picture here as far as the number line goes. We know 0's in the middle. We know the absolute value of whatever this stuff ends up being is either at positive 6 or at negative 6. So we can take that and set up 2 equations out of it. X plus 4 equals positive 6. And then x plus 4 equals negative 6. So whatever's in the absolute value there, as long as the absolute value part is by itself, and we're going to see some that we've got to do a little bit of work to before they can do that, we set up 2 equations, one with the positive, one equal to the negative, and then we solve it. Get x by itself. So these are not too bad to get x by itself. You just subtract 4. 6 minus 4 is 2. So one of the answers would be positive 2. And then subtract 4 here, and x equals negative 10. If we take each of those answers individually and put them in the original problem, 2 plus 4 is 6. The absolute value of 6, still 6. We know that. If I plugged in negative 10 into the original, Negative 10 plus 4 is negative 6, and we know the absolute value of negative 6 is positive 6. So those are the correct answers out of that. So the setup is going to be, hey, you got to take the absolute value stuff and set it equal to the positive and the negative of that number or whatever's on the other side. Let's go to one that's a little bit more involved. Not too bad, but 2x minus 7 in absolute value is equal to positive 10. Okay. So again, we're going to set up two equations because the absolute value part is by itself, and it should be equal to 10. So it's either going to be on the number line at positive 10 or on the number line at negative 10. So that's how we're going to set up our equations. 2x minus 7 equals at positive 10, and then a 2x minus 7 is equal to negative 10. And we're going to solve each of those individually, get two answers for this. So add 7. This one's not going to work out real pretty, but that's okay. Life's not beautiful sometimes. No, math's definitely not. Divide by 2 is the next step, and x is going to be 17. And I'm just going to leave it 17 over 2 as a decimal. You know, that'd be 8.5. But, you know, I leave it as that improper fraction is absolutely fine. And what you're most likely to see, you're not going to see them change it to a decimal unless there's decimals in the original problem. So let's do the other equation. If we plug in or work out here and add 7, 2x is equal to, this will be negative 3, and then divide by 2, and we'll get another fraction, negative 3 over 2. And then if we plugged those into this original problem, 17 over 2 times 2 is 17. 17 minus 7 is 10. We know that's the right number. Negative 3 over 2 would be negative 3 minus 7 is negative 10. We know that's the right number. It works for both of those. So we're going to get two answers for these absolute value equations. Let's get another one. Kind of. Sometimes this causes some folks some issues when they kind of put stuff in a different order. So I always like to do some problems like that just because it makes us practice that a little bit. Okay, so we got absolute value by itself. That's important that one side has the absolute value marks on it and the other side has all the other stuff. So once you get it there, you know, this one started out there, we can set up our two equations. 6 minus 4x equals 14. So just take the absolute value marks off and then do 6 minus 4x equals negative 14. And then just get x by itself on each problem. Should be the exact same steps on both problems. Just going to get different numbers for answers. So I'm going to subtract 6. Negative 4x is equal to be 8. And then divide by negative 4, which would be negative 2. 6 plus 8 would be 14, and that's right. And then let's do the other one. Subtract 6 again. Negative 4x, and that's going to be negative 20. And then divide by negative 4. That's going to be positive 5. 6 minus 20 is negative 14. The absolute value of that is 14. So those are the right two answers. So I'm always, anytime I've got equations, I can take those answers and plug them back into the original and see if they're the correct ones. We don't we don't ever have to guess about that. All right. So everyone we've done so far, the absolute value stuff was on the side by itself. Well, that's not always the case. Sometimes there's some other stuff that's in the way that we've got to work with to be able to solve those and get those easy equations to solve. So let's start off with one of those. Maybe something like this: 2x plus 8 in absolute value. And then outside of the absolute value, let's put a minus 6 and say that is equal to 16. So we're taking an absolute value, we're subtracting something else from it, and then it's equal to 16. Well, that's a little tough to do because, well, you got this extra thing here that's trying to take you away from that distance away from zero idea. So the key to being able to do problems like this is get the absolute value part by itself. So we want to get that thing isolated. So we need to move this -6. Let's get rid of it and move it over to the other side. And that makes things a lot easier when you do that, because now you've got absolute value of 2x plus 8. And then 16 plus 6, that's 22. That's an easy number. And now it looks like the problems we've been doing. We can set it up as two separate equations. 2x plus 8 equals 22. And then 2x plus 8 equals negative 22. And solve those. So subtract 8. It's 2x. 22 minus 8 is 14. And then a nice little division at the end. Divide by 2. X is 7. Right. Do the same things on the other problem. Subtract 8. Different answer here. So that's negative 30. Divide by 2. Negative 15. If you take each of those and go back to the original problem and plug them in and it works. They're the right answer for that. Okay. The only time you should get the same number, one positive, one negative, is if there is no addition or subtraction in the absolute value. If you just had something like, 3x or plain x inside the absolute value, that's when you can get the same answer, just opposite signs. It's most of the time you're going to get two different numbers, just completely different numbers. Won't always be one positive and one negative. One, it's always going to be just different numbers. What letter we're on here? I wrote E there, but that's not where we were at, was it? I think, yeah, it was. Maybe I'm just been a long day. Let's go to F. All right, this is a little tougher. It's got a fraction in it, and it makes it a little harder. But let's try it. 2/3, and then the absolute value marks, and then x minus 5. So it won't be too hard on you on the inside parts there. And then plus 4 is equal to 7. So for this one, again, we're trying to get the absolute value stuff by itself. So we're trying to get this part isolated. So that means we need to get rid of this thing and that thing on that side. Okay. So first thing you want to get rid of are the things that are not connected to the absolute value by multiplication. So this 2/3 we're going to do last. So let's get rid of the 4 first. That's what we want to get rid of first because it is not connected with multiplication. So we'll subtract 4, and that's going to give us 2/3 absolute value of x minus 5. 7 minus 4, that I can do, that's 3. And now we need to get rid of that 2/3. And since it's multiplying times this absolute value stuff, I need to do what to get rid of it? I need to divide by 2/3. And dividing by 2/3, you might say, well, I could flip it and multiply. That's the same thing. If you're going to use division and you're using your calculator to help you, which I figure most of us, when we're doing division with fractions, that's the quickest way to do it. 3, when we do that division, we need to put that fraction in parentheses. So 2/3 in parentheses like that. And then hit enter, and it gives me a fraction answer. So I'm going to hit math, enter, and get 9/2. So I get absolute value of x minus 5 is equal to 9/2. And it's okay that that's a fraction over there. It's not, it just means, hey, that's a, fractional distance away from 0. So now we're finally at the place where we can set that up and solve the two equations. X minus 5 is equal to 9/2. X minus 5 is equal to negative 9/2. And we're just going to solve each of those. Get x. So add 5. 9/2 plus 5. Math, enter. 19/2. And then add 5 to negative 9 over 2. Negative 9 over 2 plus 5. And I'll hit math enter. I know that's 1/2. We could, again, because it's an equation, we could take these two numbers and plug them into the original problem and work it out. Evaluate that. We should get 16, or excuse me, 7 on the left side is equal to 7 on the right side with both of those. So that ends up being the right thing. There's a couple of special case things that can happen with absolute value equations that we'll talk about, and that's it goes back to that original idea that absolute value is a distance away from 0, and distance is never negative. Okay, direction can be negative, but distance is never negative. So when we have a problem, and these are some of our favorite ones because they're the easiest. If we have an absolute value problem, and the absolute value part is by itself on one side, and it's equal to a negative number, can the distance away from 0 ever be a negative number? No. By definition, absolute value is a positive result because it's a distance, and distance is always positive. Can't go to Lowe's and buy a tape measure that has negative numbers on it. They don't sell them. Okay, they don't make them because distance is always positive. So anytime you have an absolute value, and it's got to be by itself on that side, if it's equal to a negative number, then you know, hey, that can't happen. There's no way. So this is a no solution. You don't even have to work it. You know that there are no answers that could fix that. So no solution. You could write out no solution. You might see that symbol, like a circle with a slash through it. That's the null set symbol. We talked about that the very first day of Math 100. You don't use that null set idea very often, but this is one of the cases where you can. But no solution, or the circle with a slash through it. It's a symbol for no solution out of that. Now, where they can catch you is when they might do something a little bit sneaky, and they'll try to do this. They'll go, okay, let's get them. Let's say we had 3 absolute value of x plus 6, and then minus 10 is equal to negative 6. And they'll throw that at you, and you'll get kind of excited because you say, oh, it's an absolute value equation, and it's equal to a negative one. I don't even have to do that. That's no solution. But where they're getting you at is the fact that the absolute value is not by itself yet, and you can't make that decision until that's there. Okay, so you've got to work to get the absolute value by itself. So here, if I do that, if I add 10 first, like I did on was example F, we moved that part first. 3 absolute value of x plus 6, and then negative 6 plus 10 is going to be positive 4. Oh man, now it's equal to a positive. So that tells me, okay, I probably got to keep working this thing, and I'm probably going to have to end up working it. Then I'm going to get rid of the 3. And I end up with a fraction over there again, just to get the practice, because we don't work with fractions quite enough in everyday life. Probably we do a lot of dollars and cents, but we don't do many fractions, or most of us don't. I won't say everybody does. Now, from there, it is a valid absolute value equation because it is an absolute value equal to a positive number. It's a fraction, but it's a positive number. So that means we can work this problem and get 2 different answers for it. So we're going to set them up. X plus 6 equals 4/3, and then x plus 6 equals negative 4/3. Okay. So we're setting that up and solving that. Should end up with two fraction answers out of this. So I'm going to subtract 6. And I'm just going to use a calculator. 4/3 minus 6. Math, enter. Negative 14/3. That's one of our answers. And then I'm going to subtract 6 over here. And then, so I got negative 4/3 minus 6, which is math, enter. Negative 22 over 3. So key to the absolute value equations is make sure that you get the absolute value part by itself first. If it's not already, a lot of them you see will already be there. And then make sure it's equal to a positive number. If it's equal to a negative number, then it's not gonna, you can't solve it. It's no solution. If it's equal to 0, yes, you can solve it. Go ahead and work it. If it's equal to a positive, solve it and go from there. Just work them out. 2 different equations. One's equal to the positive, one's equal to the negative. That should get you your solutions for absolute value equations. They're pretty straightforward. The inequalities they're fairly straightforward, but there are some rules we've got to know for them, and we're going to talk about those right now. All right. So let's look at absolute value inequalities. All right. So I have this saying that I use for my high school students, and they sent my wife actually is the one that told me about it. She teaches math too, so we do math problems on dates and things. But that's what all the kids think we do. It's quite funny. What do y'all do, like fractions on dates? Yeah, that's what we do. You do fractions. But she came up. I don't know if she came up with this. She told me she did. I'm skeptical if she came up with this or not, but she may have. If she did, I'm giving her credit for it. So if you hear it from somebody else, they probably got it from her, I guess. But it's this saying. It's called land of Gore. All right. She has this big long poem that goes with it that says, in the land of Gore, less thans are ands and greater thans are or, and then it's several more lines after that, and I have yet to memorize that poem. She says it without batting an eye. But here's what you got to know about this. When you're dealing with absolute value equations, and problems come from less than symbols. Or problems come from greater than symbols. And, less than symbols look like that. Or you got the equal to mark. Okay, that's a less than symbol. Looks like an L if you do your left hand. That's how I get my high school students to remember it. You probably heard alligator left, alligator right, growing up. That's how they all remember it, and I try to get them out of that because they're in high school and they're trying to, but greater than symbols go the other direction. Now, the question always comes up, and you may not have this question, but it always comes up in high school. Why in the world does a less than have to be an and problem and a greater than have to be an or problem? Why is that the rule? The rule is that way because of the distance away from 0. Okay? If we're talking about on a number line and we got 0 right there in the middle, okay? And let's say we had some numbers. Let's just say -8 and +8, just because 8's a good number. Okay? If the distance away from 0 is less than 8, where's it at? On the number line there. So if the distance away from 0 is less than 8, so let's say we had this, absolute value of x is less than 8. Where are those numbers that have an absolute value that are less than 8? In reference to the number line from the 0 to the 8 or from the 0 to the -8. Are they in between -8 and 0 or in between -8 and +8? Yeah, because like 7's in there and 7 has an absolute value that's less than 8, right? 6 is in there, 5, 3, 2, 1. All those numbers have an absolute value that's less than that. And all of them are on the inside. And when we do inequalities, when we did this back in 100, we were doing inequalities. The answers to and problems were always on the inside. They're in between. And we drew that graph like this, with the parentheses, and then we put that shading in between there. That's what we did in 100. Been a minute since we did that. We didn't do it much in that class at all. It was like one day, and then we're done with it. We moved on to other things. Okay, so less thans are ands because all of the distances are less than, so they're in between. So that's what makes it an and problem. The or on the greater than, if we were talking about that, let's just make that greater than 8. Well, if the distance away from 0 is bigger than 8, then it's going to be out here, right? It's going to be out here past 8. It's going to be out here past -8. And in inequality world, if you're moving outside, you're an OR problem. Your answers are OR. Either you're greater than -8 or you're greater than 8. So you're going away from each other. So OR problems, the reason they're that a greater than symbol is an OR problem is because your distances are getting bigger. And problems, the distances are getting smaller, so they're going to collide right there. They're going to mix together there. So that's why that's happening. But if you'll remember that saying, land of Gore, less thans are ands and greater thans are ors, that'll help you set up every one of these problems and makes it a lot easier to get there. All right, so let's look at some examples, and we're gonna do some or problems and do some and problems. Just gonna throw it at you, and we're gonna decide which one is it. What do we do? Okay. So, example I. Say we got an absolute value. 2x minus 5 is greater than 7. All right, so that's a greater than symbol right there. And that tells me that this is what kind of problem. If it's greater than, it's or, always. Absolute value is going to be on the left-hand side, and that's how you're going to tell. It's always going to be on the left, okay? So greater than symbol, it's going to be an or. All right, so that means we're going to set this up almost exactly like we did the equations, all right? We're going to set up two inequalities. We're going to set up 2x minus 5 is greater than 7, or 2x minus 5, and then we're going to flip the symbol, less than -7. Okay. Setting up two. It doesn't matter which one you put on the left side and which one on the right side. If you'd rather put the negative on the left and the positive on the right, that's fine. It doesn't matter. Okay. Just as long as you flip that symbol on the one you change the sign of. Okay. Always flip that symbol. And then solve them just like we did the equations. Nothing's different about that. You just got to be able to decide is it and or an or. So plus 5, 2x greater than 12. And then divide by 2. X has got to be greater than 6. And then we got to go over here and solve the other one. Or, and then plus 5, 2x is less than -2. Divide by 2. X is less than -1. All right. So once you get there, there's your inequalities. You can take that and put it into set builder notation just by going x such that x is less than -1 or x is greater than 6. And I just swapped the order there to show you it doesn't matter which one is in the front or the back of the or. I think on the computer program that your quizzes are on, it will usually put the smallest number first, just because it's a computer and that's the way it likes to do things. Okay, but it doesn't matter which, technically. So on labs, I don't care which one's in front, which one's in the back, as far as that goes. So there's set notation for that. So that's correct. We could also have the number line representation of this. So we could actually graph this on the number line, which is not hard to do. Draw yourself a number line. You just got to make sure those numbers are on there. So I'm going to put -1 here, -2, -3, 0, 1, 2, 3, 4, 5, 6. And just make sure there's maybe a number after that at least. And then graph those inequalities. We know x is less than -1. That's going to be a parenthesis because it doesn't have the equal to mark. If it were a equal to mark, you'd put a square bracket there, and it's going less than, so it's that direction. And on the 6th parenthesis, going to the right, just like that. I do the number line second because that makes the interval notation really easy, okay? The interval notation is read the number line. What's this arrow over here on the left? What's it going toward? Negative what? negative infinity, and it goes all the way up to -1 and stops. And then this other arrow starts at 6 and goes all the way to what? Positive infinity and stops. So there is your interval notation for that. So you have set notation. Here's the graph. When they say graph, that's what they're talking about. And then this is interval notation. All three of those. And they this book tends to mix it up in which way they ask for you to do it. So that's why I do all three on the examples here, so that you know what's going on. All right. All right, let's look at another. Oh, what layer am I on here? J. All right. Absolute value, 3x minus 8, is less than or equal to 10. All right, so we got a less than or equal to there. So that tells me that this is what kind of problem? And problems are set up a little bit differently. The way that I like to set them up, and the way that I teach you to do that, is take the 3x minus 8, put it right here, and then take the absolute value marks off of it and put less than or equal to 10, just like the original problem. Then go down here to the left-hand side and put another less than or equal to symbol and put your -10 down there. And problems can be set up like sandwiches. Okay, that's the way I always kind of teach that. That it looks like a sandwich. You got a number on each end and some stuff to do in the middle, right? So that's bread on each end, meat in the middle. If you're a vegetarian, bread on each end and vegetables in the middle. Veggie burger. Okay, so you're setting it up like that. If it's an and problem, if it's an or problem, you're going to split it into two. If it's an and problem, you're always going to have double less thans. It's never going to change. It's always going to be less than, less than. If this is an equal to mark, they're both going to have equal to mark. If it doesn't have the equal to mark, then neither of them will. Okay, so it's always going to be the same symbol on and problems. And then your job is to get x by itself in the middle. So whatever you do to the middle, you're going to do that to both ends. Okay, so if we pull the my wife doesn't like tomatoes, so if she gets a sandwich and it has tomatoes on it, she pulls the tomato out. Well, that 8 looks like a tomato. So I'm going to move it by adding it, pulling it out of the middle. So it comes out of the middle, it's got to go to the outside, right? So if I add 8 to get rid of it in the middle, I got to add 8 to each end because it's like a three-sided problem. Okay, cancel, cancel, 3x in the middle. And then just work out those. So -10 plus 8 be -2. 10 plus 8 be 18. All right. So now I got to get rid of this 3 in the middle. So it's 3 times x. So the opposite of that would be divide by 3. So I'm going to divide by 3. Okay. I'm dividing everybody by 3. Okay. Left-hand side, it's just a fraction. So I'm just going to leave it -2/3 less than or equal to x less than or equal to 18 is divisible by 3. It turns into how much? 6. Good job. All right. Set notation is just copy that inequality down. -2/3 less than or equal to x less than or equal to 6. There is set notation. For the graph, draw yourself a number line. And since we have a fraction and then a regular number, I'm not going to put a bunch of fractions on here. I'm going to put a bunch of regular numbers on there and then estimate where that fraction's at. So just kind of eyeball where it's at. So I know I got to have a 6. So I'm going to go 7, 6, 5, 4, 3, 2, 1, 0, -1, and -2. All right. So just get enough numbers on there. All right. And then these have equal to marks. So they're going to be brackets, square brackets. And I'm going one of them at negative 2/3. Negative 2/3 would be about right there. So right there, I'm going to put a bracket, and I'm going to open it up to the right so that my answers are going to be in the middle, because it's an and problem. Then I'm going to go to 6, put a square bracket, and I'm going to open it toward the other bracket. And my answers are all these numbers in here that have an absolute value that is less than whatever we started with, 10. Okay. If you plug those numbers in, that whatever works out on the inside of the absolute value is going to be less than or equal to 10. Okay. So there's the graph. Easy to do. The graph being done makes the interval notation easy, because all you got to do is just copy that. Okay, it's a square bracket, negative 2/3, comma, 6, square bracket. Okay. If you got the graph done, the interval's easy. If you're not really good at interval, which you hadn't had a lot of experience with interval notation, or most people that I've had in 100 and 110 haven't. Most people I have in 140 haven't. It's just you don't use it much. Okay, so it just takes practice. All right. So there's this an and problem. Remember, it's all dependent on what's going on here. Is it a less than? Then it's and. If it's an and problem, we're going to set up a sandwich. If it's a greater than symbol, we're going to set up two different ones and put or between them. It doesn't get any more complicated than that. Let's throw a curveball here. My favorite pitch when I was much younger and more athletic was to throw a curveball, especially to guys that couldn't hit one. So if we had 2 minus 5x in absolute value, and then let's put a greater than or equal to 4. We got an equal to mark, so we know it's going to have brackets on the set notation in the graph. It's a greater than symbol, so we know that this is going to be or. Good job. So it's an or problem. Okay. So we're just going to set up two problems. We're going to set up 2 minus 5x is greater than or equal to 4. So just take the absolute value marks off, copy everything down. Or, and then 2 minus 5x, flip the symbol, change the sign. Flip the symbol and change the sign so that you're going to the outsides, because it's an or. That's why we got to flip that symbol. And then just solve each of those separately. Okay, so I'm subtract 2, negative 5x is greater than or equal to 2. And then here's the thing that sometimes catches us on an inequality. To solve this one, we've got to divide by negative 5. Anytime we divide by a negative when we're solving inequalities, we have to flip the symbol. So that flips around to a less than or equal to negative 2/5. Okay. It doesn't change the fact that this is an or problem. That hasn't changed. It's just changed the way that symbol looks. Okay. Same thing on the same steps for the other side there. We're just going to subtract 2. And negative 5x is less than or equal to negative 6. And then divide by negative 5. Again, because we're dividing by a negative, that's going to flip the symbol to make it greater than 6/5. Okay. So those are our solutions. The set notation, it's in the right order, so I'm just going to copy it down. There's our set notation for that. It's the inequalities. And then let's get the graph. So number line, and it's got fractions on it. So since both of them are fractions and they're both over 5, I can make this pretty easy on myself by just doing all fractions since they're so similar. If I just, I go, okay, let's do 7/5, 6/5, 5/5, 4/5, 3 over 5, 2 over 5, 1 over 5, 0 over 5, negative 1 over 5. The line's not long enough. Negative 2 over 5, and then one more, negative 3 over 5. So I'm just changing the number that's in the numerator of those fractions. That makes that number line easy to do out of that. If they were not both the same denominator, I would probably just do regular numbers and estimate where the fraction was. Not too picky on the number lines. Most of the time on like the Canvas quizzes, they're gonna have one already drawn for you. It's already marked up and everything. You're not having to create it on your own. On the labs, that's when I'm not crazy picky about those. If you get this part right and you're off a little bit on your graph, I'm not going to count off very much, if anything. Okay, if you're getting the inequality right. So again, we're gonna graph this. So less than or equal to negative 2/5. I'm gonna go there. I'm gonna put a bracket and go to the left. Go to 6 over 5. Put a bracket. And go to the right. And that makes the interval notation super easy because that's negative infinity all the way out here on the left, and it goes up to negative 2/5. Bracket, union, bracket, 6 over 5 to positive infinity. Do a good job with my bracket there. Make that better. And there's your interval notation for that. So less thans or ands, greater thans or ors. If you divide by a negative, you got to flip the symbol. You got to make sure that absolute value is by itself first, whether it's an equation or an inequality. Make sure that absolute value is by itself first. One thing, we got one more problem to do in this section, and then we'll take a short break and then come back and get the third section of the night, because it's completely separate from this stuff. So the last thing, one letter here, L, is an equation. Looks bad, but it's not. All right. So this is an equation that has absolute value on both sides. Absolute value on both sides doesn't make it that much worse. It's got letters on both sides too. That's what probably makes this a little harder, is the fact that it's got variables on both sides. The absolute value on each side just means, okay, I just need to pick a side to start with and work from there. Okay. So the first thing I'm going to do is I'm going to work this problem. I'm going to work absolute value of 4x minus 3 is equal to x minus 6. Right? And then I'm going to work that as an equation. Right? And I have the absolute value by itself. Right? It's already by itself. If this is my first equation that I'm going to work, then I can set up 4x minus 3 is equal to x minus 6. And then 4x minus 3 is equal to the negative of that whole side. So negative x minus 6. Put it in parentheses. Okay, so we're taking this equation and splitting it into these two things. Okay. All right. From there, we solve those just like we would any other algebra problem. So I'm going to subtract x. So that's 3x minus 3 is equal to negative 6. Add 3. And 3x is equal to negative 3. Divide by 3. That's negative 1. That's one of the answers. This one's a little tougher because you got this negative hanging out here in the front. Well, that's really a negative 1 hanging in the front. So I'm going to distribute that so that I get negative x plus 6 on that side. And then work it. Because now I've gotten that multiplication out of the way, and I can add x And that gets me 5x minus 3 is equal to 6. And then I add 3. That's 9. And then I divide by 5. And I get another answer. Okay, so I got 2 answers. But here's the kicker to this, is the fact that I really had 2 absolute value problems to do. I did one of them. I did the absolute value of 4x minus 3 is equal to x minus 6. What if it was the other way around and I needed to do the absolute value of x minus 6 is equal to 4x minus 3? Let's see if it gets us different answers. Because it changes things, right? It negates a different side. So I've taken that equation and I've turned it around so that absolute value is still on the x minus 6 and not the 4x minus 3. So that means I've got 2 new equations to do. And I'm going to move down here to the below that to do that work. All right. So far, I have 2 answers. I've got -1 and 9/5. I'm going to split this up into 2 equations. X minus 6 is equal to 4x minus 3. And x minus 6 is equal to negative parentheses 4x minus 3. So I'm doing the exact same thing, just with the other side is what I'm doing here. So nothing, fancy. This is tough. And these don't come up very often. You might see one of these on a Canvas quiz, one of these on a lab, and I've seen this on the final once in like 5 years of teaching this class. It doesn't come up very often. All right, just so you know. But I don't want to send you out of here and you've not seen it before. Before you see it on a quiz or a lab. Okay, so let's just solve these. It's not incredibly bad here. So minus 4x. That's negative 3x minus 6. And then negative 3. And we may end up with the same answer twice, and that's okay if we do. That just means we didn't find a new one. We found the same old one. And I didn't add right there. Negative 3 plus 6 is 3, and that's -1. Hey, that's one we already found. So I didn't find a new one there. I just found one of the ones I already knew about. Just happens to be the same number. And let's see if that happens over here on the other one. Maybe it does, and we can negative 4x plus 3 this time. I'll add 4x, and my brain is already doing the math. So that's 5x minus 6 is equal to 3. And it looks like it's going to get me the same answer as well. So I'm not going to get a new answer out of that. And depending on the numbers and if there's things in front of the x or what kind of add and subtraction is going on there, could be a case where we might end up with something else. And that's going to be 9/5 because that's the same problem I just did. 9/5 equals x. So sometimes you get different numbers, sometimes you get the same ones, and that's okay. And that works out for those 2 sections there. So absolute value equations and inequalities, not just hard algebra that we're doing right now. The next section is a little tougher algebra. I'll go ahead and write up the practice problems that you could do for these 2 sections, and then I'll go ahead and do this. 99 odd. And then 1.8, 1 through 67. Whether you've got the 11th edition or the 12th edition, whatever page those are on, I think there's like 1 or 2 page number differences in the books. Just those numbers out of there will get you there. Let's take a short break, and then